We are continuing the electromagnet again because some of the students asked me some question related to this. One question was why not the naked we are not using the naked wire in making electromagnet. Instead of that, we are using insulated copper wire. Why it is not naked wire? Now, I want to tell you some other matter related to this question. Current and magnetism has very close relation. If we have a straight conductor like this, and if current is passed in this direction, then this current carrying conductor produces magnetic field around it, and the magnetic field is somewhat circular like this, and its direction, the magnetic field has a definite direction also, and this is the direction of magnetic field. This is interesting matter. A current carrying conductor has magnetic effect. It produces magnetic effect around it, and that's why it has a circular magnetic field. But the same conductor is if made like this, is torn this way. I told in previous class also, this is solenoid, and this is the example of solenoid. The insulated copper wire is torn in this way. At this time, the magnetic field strength is found very strong. Around a straight current carrying conductor, magnetic field strength is less, but around a solenoid, magnetic field strength is high. Now, I want to show this. This is a magnetic compass. It always turns towards north and south direction. There is a needle magnet pivoted through its center, and it is turning towards north direction and south direction. This is needle magnet inside it. But this solenoid is when placed near to it. Look at this. There is no effect because this is made up of copper wire and it is insulated. Now, if the same is connected to a cell, then current passes through it. Now, current passes through it. Look at this. Current carrying conductor has effect on this. Look at that needle magnet is turning. What it means? It means when the insulated copper wire is torn in such a way that it forms a solenoid, then that solenoid has a reasonable amount of magnetism around it, and that can be seen by the help of this needle magnet. That is called compass, magnetic compass, which is placed inside a circular box. Okay, if we use a piece of iron inside the solenoid, if we use a piece of iron, then this solenoid contains a piece of iron inside it. Now what is seen? What is seen at this time? The same magnetic field strength is now increased. Look at this. It's increased. Now, what is happening here? Current is not passing through this iron piece or steel piece. It is passing around the steel piece. But this steel piece intensify or magnify the effect of this solenoid and the magnetism of this solenoid. It has also magnetism, but the same can be intensified by inserting a piece of iron inside it. And that's why instead of this solenoid, if we use naked wire, then what happens? Instead of flowing the current in the circular pattern, the naked wire, when touches this point, then the current start to flow from this point to this point. I mean to say, current passes through this piece of iron. And if current itself passes through this piece of iron, there is no existence of any solenoid. And actually, solenoid has magnetic field around it. And a current carrying conductor has very negligible magnetic field around it. And that's why the current carrying conductor has very negligible magnetic field around it. That's why naked wire is not used in making electromagnet, because when naked wire is used, current passes through that piece of iron, and instead of passing through the solenoid, it passes through the that piece of iron, and there's no more existence of this solenoid, because solenoid now doesn't exist if current passes through it. So we cannot make electromagnet by using this naked wire. Now there's another question also. There was another question also. Some of the students asked me that why this solenoid is not turned in two different direction. The question was not so clear, but what I understood, instead of turning in one of the direction like this way, why it is not turned in both the direction? So this question is related with the pole of the magnet. Let's say here we have a piece of iron, and if it is wound with insulated copper wire like this, insulated copper wire like this, if it is turned this way, then what happens? If this end is connected to positive terminal and another end is connected to negative terminal, then what happens? This positive, this is negative. Okay, now current flows in this direction and comes out through this end. Okay, now if we see this piece of iron from this side, then the direction of flow of current is anti-clockwise. Look at this, it is going this way, and if it is turned towards ourselves, then what, this is anti-clockwise direction of current. If the direction of flow of current is anti-clockwise at the end of the solenoid, then north pole produces at that end. And look at this side, if we watch this end from this side, then what is seen? Current flows up from our side and goes down from behind. And if we turn it towards ourselves, then what is in the direction of flow of current is this clockwise. And if the direction of flow of current at the end of the solenoid is clockwise, then south pole produces at that end. This is the method of declaration of north pole and south pole at the end of the electromagnet. Now, if we are turning a piece of wire this way, and again we are turning towards this direction, then at one of the end, the direction of this solenoid, the current in the solenoid may be clockwise and anti-clockwise also. If both the sides, anti-clockwise and clockwise direction, if we wound this solenoid, then what happens? The end becomes neither north pole nor becomes south pole, because anti-clockwise direction flow of current produces north pole, and clockwise direction of flow of current produces south pole at that end. If the solenoid is wound in such a way that it is turned towards right hand side also, left hand side also, right hand side also, then the resultant magnetic field won't exist, and there is no any pole at the end, and so magnet cannot be made. Okay, I think I answered the question asked by the student. This much for today.